Hello everyone, this is part 2 of the Texas Instruments interview question solution. Let's go into this question, and if anyone has not watched the previous video, please go and watch. I have discussed all the questions, and in the part first I have discussed RC questions, and that was very important. So if you have missed that lecture, please go and watch. So let's start from this. So this question I just have not solved in the previous video. So just quickly look into this. So this was the question. So here, I'll just remove this so that we can have a bit space here. Okay, we have to plot V out. We have to plot V out, and when this capacitor is charged to +2 voltage previously, and this input is step input from 0 to 4. Okay, so first understand this question. I will just briefly explain what is happening in this question. So many of the students get confused if they get this type of questions. So I will just make you understand what this question is, so that if you have this type of questions, uh, then you can able to solve. So what do you mean by this capacitor is being charged to 2 volts? So many of you think that if this is charged to 2 volt, then this will be also charged to 2 volt, right? But this is not. This is not correct. So what this question is being referred to, uh, at t is equal to before t is equal to 0, this capacitor was open circuited. This capacitor was open circuited, and this was charged to +2 volts. So this is the meaning of this question. This was charged, and at before t is equal to 0, this voltage was 0. So what does mean? What does this mean? This is grounded. Okay, so this was the circuit before t is equal to 0. This is open circuited, which is charged to +2 volts, and this is the circuit, right? Yes, so what will happen at t is equal to 0? At t is equal to 0, both this, I will just use the different color. So both this and this will be get to +4 volt, as well as this will be connected. Okay, so this will be connected, means this will be connected here. Okay, so now what do you think what will happen? Just think about it. So what happens is, as soon as you connect this capacitor to this capacitor, there is no resistor in between this. So this plate is being directly shorted with this. So some of you will tell you have this resistor, but no, this is between these two plates. There are no connection. They are physically shorted. These two plates are physically shorted. So we can apply the charge conservation theorem here. Charge conservation theorem here. I think spelling is correct. If it is not, please forgive me for this. And what you have is the charge before is equal to charge after. So charge before is 2 volts into 4C is equal to V out into summation of this two capacitor, which is 6C. Okay, so what you get, you will cancel this 3, and you will get V out is equal to 4 by 3. V out is equal to 4 by 3 volts. So as soon as you connect, as soon as t is equal to 0, you have to connect that charged capacitor to the circuit. That's why you get this voltage. Okay, so what will happen if you are not connecting this voltage? What will happen if you are not connecting the input voltage? So you will get something this type of circuit. Okay, so at t is equal to 0, you will be getting 4 by 3, and now due to this resistor, this will carry some current because you have 4 by 3 here, and the voltage difference between these two nodes are 4 by 3, so this will carry some current, and that current will be ultimately supplied by the capacitor. So it will be totally discharged if the voltage source was not connected, but here the voltage source is connected. So what will happen? Think about it. So the voltage source is connected, which is 4 volt. Okay, so this is 4 volts and this is 4 by 3. So that means this node is bigger, so the current will be traveling to this, and this will V out will not discharge, but it will get charged. So how to draw the waveform? I will just shift it upside. Sorry, shift it upside. So this is it goes. So we'll have some space to draw. Okay. Yes. So what will happen? It will start from 4 by 3, and up till what value it will reach? This voltage will reach up to what value? It will reach to V in. Why? Why it will reach to V in? What happens at V in? The current from this branch becomes 0, and there is no further charging. That's why it gets settled. So sometime interviewer can also ask you this type of questions. So make your basics strong. So you will have this type of waveform. Okay, got it. So this is 4 by 3 volts, and this is 4 volts. This is T and this is V out. Okay, and if you see the current, at first this will like the current will also start from that. It is minus into 1. So this is the starting current, and then it goes to 0. So you can plot that. So this question was remaining in the last video, so I've just completed it. So let's go to the very important topic, that is Opamp. So I will just quickly see. Okay, so now we'll see the Opamp questions, and this Opamp questions in the interview lasted a bit because they asked me to discuss so many things. So one by one I will explain. So this was the question. We'll just, so everything they told me to assume ideal. So we'll just remove this to make a bit space here. Okay, so this was the question. We'll also remove this. So we have a Opamp like this, where this type of configuration is there, and they have asked me for a system to be in negative feedback, what should be the polarity of A and B. So the immediate thing that we get is this is the feedback, this is the feedback, so this should be negative. So anyone wondering that this will be negative, the answer is wrong. This is not correct. Because, so okay, so so I will just tell you how to tell which feedback the system is, so that if you encounter this type of question, then you would be able to solve. Okay, so let's see. So we have, this is the V out. Okay, so whatever, so first thing that we do is we just disconnect the source, like we disconnect the input source, and as it was the voltage source, we connected it to the ground. Okay, so and we also disconnect the input given to the supply. So what we will do, we will check what is the, I'll just use a different color. So we will just check what is the Vx in terms of V out. how much it is getting feedback, that we'll see. So here they have told V out is this, but actual V out of the op-amp is this. So we'll name it as V dash. So yes, so the system to be in negative feedback, what it should be, if the V out dash increases, the op-amp has to make it decrease. That is negative feedback. And if V out increases and the op-amp should increase it, that is positive feedback. So one thing is clear, this is the fundamental thing. In negative feedback, if the V out increases, the op-amp will try to decrease it. That is a negative feedback. That is very much sure with the name. You are getting a negative feedback. So if you are rising up in the life and someone is giving you the negative feedback, it pulls you down. So with this you can see. So that is the negative feedback. So same thing we'll do. We'll increase this. V out dash increases. So what will happen? This is the analog buffer with a gain of -1. So if this tries to increase, so this analog buffer will decrease it, as it is having a minus gain. So if this increases, this decreases, and if this voltage decreases, what will happen? Vx will also decrease, because Vx is equal to V out into R divided by 2R, which means it is V out by 2. So if that increases, if V out decreases, Vx will also decrease. Okay, so if Vx decreases, we want the op-amp should decrease the V out. Okay, so now just assume, if I assume this as negative and this as positive, so what will happen? The inverting terminal is being reduced. So what will happen to the V out dash? V out dash is a gain of V plus minus V in. So if this voltage decreases, so this difference increases, right? So if the difference increases, V out will increase. So that means this polarity is not correct. Okay, this polarity is not correct, and so we'll just reverse this polarity, because we just have two options. So if I reverse this, now I'll check. So if Vx decreases, the positive terminal voltage decreases, then V out dash will definitely decrease. So that means this is the correct polarity. Okay, so if Vx dash decreases, we have V out dash is equal to A into V plus minus V1. So we are putting it as Vx minus this. So if this increases, if this decreases, V out dash will also decrease, which is opposing the change of initial increase of V out dash. Initial, I'll just increase of V out dash. Okay, so let's go to the next question. Yes, here they have asked me to calculate V out, and then they asked me what will be the V out if polarities are changed. So let's just quickly make the room for the question, for the answer. Okay, so now whenever you see there are two feedback paths, first of all directly calculate what is the overall feedback of this system. So how to calculate the overall feedback of the system? So the same thing that I have explained in the previous thing, just remove this, disconnect this, and now calculate V minus and V plus. So and short this terminal. So Vx is equal to V out divided by 2R, and V plus is V out, sorry, this is 3R into R. So from this, what you can see, from this two statement, what you can say is, so, okay, let it be. Okay, so from this what you can say is, this is dominating this as 1 by 2 is larger than 1 by 3. That means negative feedback is dominating the positive feedback. So the overall system will be in negative feedback itself. So, and why we are finding this? Because your virtual short will be only valid in negative feedback. You can't apply the virtual short if the feedback is positive. Okay, so what will happen here? So now this is Vx, assume that Vx, so V minus is equal to V plus, so Vx is equal to V out by 3 into 1. Now just make a simple KVL, then you can solve it. V1 minus 1 divided by R is equal plus V1 minus V out by R. So from the simple KVL you can get into the conclusion. So this is V out by 3 minus 1 plus same V out by 3 minus V out is equal to 0. Okay, I think I have made some mistake. No, it's correct. Okay, so this goes to V out by 3 plus V out minus V out is equal to 1. So this goes as V out is equal to minus of 3 volt. So this is the answer. I hope you get this, and in the next part I'll add one more page here. So in the next part I'm just copy this circuit. In the next part they told if what will happen if I make this positive and I make this negative. So now V plus will be V out by 2 and V minus will be V out by 3. Now the positive feedback dominates the negative feedback. So what will happen? In this case, what will happen? So let's try to see intuitively. So this Opamp behaves as a positive feedback configuration. The system behaves as a positive feedback configuration. So if V out increases, it will try to increase it again. Okay, so assume if this is 1.1, so this will again increase to 1.2, then it will increase to 1.3, and then it will be going to increase up till 1.1, 1.2, it will up till go to VDD. So, and if this goes to, if it decreases 0.9, 0.8, 0.7, so it will continue to decrease so on, and then it will reach to VSS. So from this two thing, what you can see, you see this as this acts as a comparator. Okay, so a small change in the output will make it to shift to VDD and ground. So this acts as a comparator. So they was like, okay, fine. Then they moved into the next question. Okay, so now this is the question. I'll make the space for the next one. Yeah, so here you can see you have a negative path, and from this negative path, this op-amp is in negative feedback configuration, so this two voltages are same. So v plus is equal to v minus is equal to 0, and this is 0, and the current here is 1 by r. So you will have a constant current. Okay, so you have a constant current and the current here is 0, so all the current will be passing through this. So 1 by r current will be passing through this, so this current will be 1 by r. So when we have a constant current passing through a capacitor, so we have a, this is the equation. So if the current is constant through the capacitor, you get a constant slope. So this is the equation of capacitor. So this is how the capacitor will charge. And now the thing to notice, this voltage is set to 0 and this capacitor is being getting charged. So this voltage is increasing, VC is increasing, but this plate is set to 0. So what will happen? This plate has to decrease. Okay, so we have sorry, okay, so the VC will increase like this, sorry, not like this. VC will increase linearly with a slope of 1 by RC. This is VC, but what will be the V out? Yes, what will be the V out? So think about it. V out will go in negative because because this is V out and this is minus of VC. Minus of VC means it will go down. And then they asked me, will it go to minus infinite? I told no, this depends upon the supply voltage, and then it will cut off to this value, like not cut off, it will saturate to this value, and this value will be VSS. This is time. Okay, so this is the V out plot and this is the VC plot. Okay, and then again they have asked me what will happen after this voltage, what will happen to the voltage of V minus. Okay, so this was the good question, and I got I got stuck here in interview, and then they have given me some inputs, so let's discuss that. Okay, I will just copy this circuit again. Okay, so I will remove this. Okay, so now tell me, this voltage is being saturated to minus VSS. Okay, sorry, not minus VSS, it is VSS. So this voltage can't change now. This volt cannot be changed, and this voltage is fixed to this. Okay, but we have 0 here, we have 1 volt here, and if there is a voltage difference between the resistor, there will be some current, and this this is 0, so this capacitor has to charge because there is a current flowing it. So what will happen? This is also fixed to 0, this is also fixed to VSS. So what will happen? They ask me what will happen, because both of them are fixed. So where will that current goes, and what will happen to the charging of the capacitor? Think about it. So the answer is, this is ultimately fixed. This cannot go beyond the VSS. So this is fixed. This is for sure. So that means this voltage will be changed now. Why? What will uh, what will happen to the negative feedback? What will happen to the virtual short? Virtual short, because at the previous it was a negative feedback and this difference was 0. Okay, and this difference was 0 because we have an output which is increasing with the difference of this. Now the output is saturated, so this condition is no longer satisfied. That's why this voltage will increase. V minus will increase after this voltage hits him. So at this time, so let's consider at T1. So now at T1, V minus will start to increase, so as to keep increase the VC. So what is VC? VC is V minus of V out. So at the starting this was decreasing and VC is increasing. Now this V out is constant, so the only variable is V minus, so V minus will start increasing, and then we can plot a graph of this. What is happening? Sorry, just wait a second. Yeah. So so suppose this has V minus. So up to this point it is 0. Up to this point it is 0, but after this Vs has reached, it will start to increase. Up to what value increase? It will increase. It will increase to 1 volt. And sorry, this is not linear. So they have also asked me what will be the nature of this increasing. So I took some time. So you also take some time and answer this. So intuitively I will tell, if this is one thing is sure, that V1 will increase, and will increase because of the charging of the this capacitor, and this capacitor charging depends on what? It depends on the current. So current is V in minus V and this. So now the current is also changing because V minus is getting increase. So if V minus is increasing, the current is also uh, decreasing. So if current decreases, the rate of change of the voltage also decreases. So this gives to our famous equation, famous curve, that is exponential curve. So this will be an exponential curve, and V minus will settle to this is V minus curve, and V minus will settle to V in, that is 1 volt. So this was the good question that they have asked. They spend a lot of time on this. They asked me what will be slow, what will be this, think about this, think about that. I took time on this. So in Texas interview, majorly they will find some spot where you are getting stuck, and at that spot they will give you some inputs, and they will check if you're not knowing something, and if they are giving some inputs to you, are you able to convert that inputs into some input to some valuable outputs, or the correct output they are expecting. So don't panic in the interview, just listen to whatever they are saying and respond them correctly. Okay. Okay, so yes, this was the now in this question, they told me remove the voltage source and connect the current source. Okay, so now the current is constant. So what do you think what will happen? Because the current is constant, the current has to be there, the current will be there. So the only change that will happen in this is, think about it, what will happen at start. At start we have a constant current. What will be the slope? V says 1 by C into I into dt. So I is constant, so R is not needed here. I is constant, so Vc is equal to 1 by C into dt. So the slope will be minus 1 by C, and the earlier the slope was minus 1 by RC. Okay, this was the change, and this will settle to Vs. Okay, so now after Vs, what will happen to Vi? I'm sorry, inverting voltage. So up to this, the voltage is 0. So now, what will be the behavior after this? We have made this exponential because the charging current was also decreasing there, but here charging current is not decreasing. Charging current is constant. So that's why we will also have a constant slope like this, and then it will settle. Okay, no, sorry, this will not settle because at that point this voltage was being settled because the current, this voltage and this voltage was getting constant, but here we have a constant current source. The current will not be 0, so it will increase, so on. And they have also asked me, is there any limit for this voltage? So I told there is no limit. The only limit that it can have is the limit of the current source, up to what it can supply, and they said it is an ideal source, so there is no limit to this. Ideal source can provide a fixed current with whatever the value of the output it has, because if you remember, the what is ideal source? Ideal source is this ideal current source. This is current and this voltage. It can give whatever amount of voltage you have. Okay, so just delete this for better understanding. So okay, next. Yes, this was the, again, this was also a good question, and good conversation happened between me and the interviewer in this question. So assume everything is ideal now, and then tell what will be the input resistance and output resistance of an op-amp. Okay, so input resistance, for the input resistance, what you have to do, you just connect a voltage source here on the node. We'll just use different color. Okay, so connect a voltage source here, test voltage source, and measure what will be the current across it, and whatever current you will get, you just divide this by this. Okay, so this is your this how you can find the, okay, so this is not correct, this Vt by I, sorry. Okay, so this how you get your input resistance. Okay, so now see, as this is a negative feedback, so this voltage will be equal to this voltage, and as this is not having any input current, so this is 0, so this is also 0, so the current was 0, correct? So this voltage is 0, so as the current is 0, this voltage will also be 0, so now this is also 0. Okay, so now you can apply the KVL. Vt minus 0 by R is equal to It. So now It is Vt by R, so your Z is R. Okay, so you got this value. Good. Rn is equal to R. Okay, so now now let's go to the R out. So in this R out went a bit long discussion, so I will just tell you what is R out. So this is an ideal amplifier. So what is the characteristics of ideal amplifier? Uh, in my previous videos, I have discussed the characteristics of ideal amplifier in very detailed manner. So I will just quickly tell you what is the ideal characteristics. Rn is infinite, R out is 0, gain is infinite, that is open loop gain. Okay, so this three is the major. This three are the major, and we have also other ones, CMRR, PSRR, all those things is also there. If you want to check, you can check my previous videos. I have detailedly explained why the R out has to be infinite, like Rn has to be infinite, R out has to be 0 for an ideal amplifier. You please check that, because that is very important. Then only you can answer this type of conceptual questions. So the input resistance is 0 and you want to calculate. So first way of solving was, we'll copy this. Okay, just I will not copy this. I'll just make circuit here. The first way of solving was that this is connected to ground and we are calculating. This is R and this is R. So what will be the resistance here? There you have two parallel paths, but you have a ground here. So of course R out will be 0. They are no other thing. But this is this this type of explanation is only good when you are having a good knowledge what you are doing. So there is an other way of solving this. Other way of solving this is V out, and for calculating the R out you apply a test voltage here. So this is Vt, so this will be Vt by 2, and if this is Vt by 2 and this is an ideal amplifier, and if Vt is higher than V plus, this voltage will be go to minus Vss, or if it is ideal this goes to minus infinite. So what does this means? This draws an infinite current. Sorry, this draws infinite current. It draws the current in, so it draws an infinite current, and we have Vt is equal to R out is equal to Vt by I. So if this is infinite, then it is 0. So this is the proper way of solving. This is the proper way, and this is the shortcut that you can apply. So please remember the basic concepts of this thing, because this type of shortcut will not be applied like everywhere, because behind this there are several assumptions that they have made, that the gain is infinite, the output resistance is 0, and so on. But this is the pure thing that you can see. So every time if you have to calculate the resistance, just apply a test voltage, calculate the current that is flowing through it, and you're good to go. No other exception can hide through this. Okay, so whatever I was explaining, I will explain in this question. Now they told me to do this because at that time I did this. I have gave them this explanation. So just to check my conceptual understanding, they gave me this question, and they asked me what will be the R in and R out. Okay. So in this question, Rn is same. This is 0. This is 0. So Rn will be this one. Okay, I will just remove this so that we can have a good space. So Rn is R. Okay, we have this. Now just calculate the R out. So the this is all ideal amplifier. So output resistance is 0 and this resistance is connected. Output resistance is 0, so that means this is connected to ground, and this is an ideal amplifier. So what will happen, you will just draw this type of circuit. And this is ground. So if you calculate the R out from here, you will see this is R, this is R, and this is also ground, sorry, because this is ground, right? So this is also ground. So what you have, R is equal to R in parallel with R, you get R by 2. But this is wrong. This is wrong answer. This is not the correct answer that they expect, and that's why I told that was a shortcut thing. So you should not follow that. Now just see what will be the correct answer. Now the earlier way that I told you, connect VT here and calculate the IT. Okay, so this is VT, that means this is grounded. This is VT, that means this is VT by 2. So again, if this is inverting terminal is VT by 2 and non-inverting terminal is 0, that means the output will go to minus infinite, and VT minus infinite will be minus infinite only. So still this amplifier will draw infinite current, and if it draws infinite current, so just I will just write whole equation so that you can get a clarity. VT minus V out by R is equal to plus VT minus 0, this loop I am calculating, VT minus 0 by R is equal to 0. And if now V out is minus infinite, why? Because V minus is VT, and if V minus is VT, the output goes to minus infinity. So this is R, this is VT by R, so this is infinite. What does this mean? This means the current is infinite. If the current is infinite, the resistance is 0. So that means output resistance is 0. Still output resistance is 0 because we have R out is equal to VT by IT. So if IT is infinite, VT infinite, this goes to 0. So still you have a 0 output impedance, and this is what they are trying to get from me. But I will ask you one other question. Assume this gain is not infinite. Assume there is a gain of this A, and assume the output resistance is 0. Okay, so output resistance is 0 and the gain is A. So what will happen? Now this will not be minus infinity. This will be VT by 2 into A. Now again you have to solve all these equations. So this is 0, you can neglect this R, then what will happen? VT minus Vt into 2 into A plus Vt is equal to 0. Not 0, sorry, this is not 0, this is IT. Please correct in previous things also. This is IT, so Vt will be Vt 1 minus 1 by 2 plus 1 is equal to IT. So you have this kind of equation, Vt by IT you want, so you will get 2 2 minus 1 by 2. So this is the output resistance that you will get. So from this also you can see, if the gain is infinite, so what will be the output resistance? 0. So at last you will get R out is equal to 4 minus A into 2. Okay, so this is the R out if gain is finite. Okay, so this was the explanation, and in the next video we'll explain other questions, and we are remaining with some 2 3 very important questions. This 2 questions was very important because like 20 minutes I think they have spent on this questions, and in this question also I fumbled, and then they gave me inputs and the things was good. So please wait for the other video. I will quickly upload it because in one video it is not possible to give my 100%. So that's why I am making a chunk of it so that I can deliver it in the better way. Okay, so please subscribe the channel and stay tuned. I will upload the other videos, and I am making a Telegram channel, so I will put the Telegram channel in the link in the description, so you can join that, and if you have any doubts you can post into that Telegram channel. I will definitely try to solve your all the queries whenever I got a free time. So thank you for watching. Bye bye.